Welcome, Math AH. This is lesson 5.2a, and we are looking if things are proportional or not. And this is a review from 6th grade, so it should be something that you understand. Equivalent ratios are considered proportional. You can use bar models to help you determine proportionality. Example, in period 1, the ratio of students wearing shorts to students wearing pants was 1 to 3. In period 2, the ratio of students wearing shorts to students wearing pants was 4 to 12. Is the relationship proportional? So basically what we're trying to figure out here is, are these equivalent fractions? Is 1 to 3 equivalent to 4 to 12? That's what we're trying to justify, whether it is or whether it is not. So one way we can do that is with the bar models. So here we see 1 pair of shorts to 3 pants, and then we see 4 pairs of shorts to 3 pants. Notice how each ratio can be depicted using the same number of parts for shorts and for pants for each class. This means the two ratios are proportional. So what I can see is that in each of the sections of the bar, if I multiply by 4, I am multiplying by the same scale factor each time. Okay, I just increased what's in each section. I made it 4 times as much. And we see that's one reason why these are equivalent, is because there is a scale factor of times by 4. So if we can identify the scale factor, then we can show that they are proportional. All right, number 1. Draw bar models to determine if the two ratios are proportional. In one box of cookies, the ratio of chocolate chip cookies to oatmeal cookies is 3 to 8. So remember, it goes in the same order. If it says 3 to 8, what came first? So the 3 is representing the chocolate chip cookies, and the 8 is representing the oatmeal cookies. Okay, so I need to pay attention. If I have 3 chocolate chip and 8 oatmeal cookies, in total I have 11. So I need to break 11 parts of my boxes. So I'm making a bar model with 11 sections. 6, 7, 8, 9, 10, 11. 3 of those sections are chocolate chip cookies, and 8 of those sections are oatmeal cookies. Okay, and in the first ratio, we know that there is 1 cookie in each of those sections. 1 chocolate chip, 1 chocolate chip, 1 chocolate chip, and then 1 oatmeal cookie in each of those sections. Okay, so that's our base bar model. We want to know if we can cut the other ratio in the same manner in 11 sections, but there'll just be multiple cookies in each section. So I'm still making a bar model with 11 sections in it. Just like up here on the one above, we saw each bar model still had 4 sections. There was just more stuff in each section. Okay, so we got chocolate chip cookies, and we've got oatmeal cookies, and we've got total. There was 3 chocolate chip, 8 oatmeal for 11 total. And now we're trying to figure out, is it proportional to 12 chocolate chip cookies and 32 oatmeal cookies? Okay, so we think, is there a factor I can scale up by? And I see, oh yeah, 3 times 4 is 12, and 8 times 4 is 32. So I know that here in each section, there's going to be 4 of the type of cookies. So when I'm doing this bar model, in each section, there's now 4 chocolate chip cookies, 4 chocolate chip cookies, 4 chocolate chip cookies, for my total of 12 chocolate chip cookies. And then on my oatmeal cookies, I have 4, and I have that 8 times to get to my 32 oatmeal cookies. Okay, so I know that they're proportional because I could still make 11 total parts. I just had more things in each section. Okay, so the question is, are these proportional? Yes. 3 to 8 is proportional to 8 to 32. B, the ratio of cats to total pets in a first pet store is 3 to 9. In the second pet store, the ratio of cats to total is 6 to 8. So now what we have to pay attention is they're not giving us a part to part, they're giving us a part to whole. Okay? So we have cats. And then we have something else, dogs, guinea pigs, iguanas, other. And that's getting us to our total. So in our ratios, we always need to pay attention. Are they giving us a part to part, or are they giving us a part to a whole? Okay, my first one is 3 cats to 9 total. And the next one is 6 cats to 18 total. And we're trying to figure out, are they the same? And I know we can look at the numbers, but we're trying to do it with the bar model. So first thing when I'm looking at this is I don't really want to draw 9 total sections or 18 total sections when I don't need to. Yeah? 3 to 9 reduces to 1 to 3. So I always want to think about what can that reduce to? This reduces to 1 to 3. So I know I need 3 total sections in each of my bar models. Okay. If I have a 9 total in the first one, then I know there's 3 in each section. If I have 18 total in the other one, I know there's 6 in each section. The first section represents the kitty cats. And the other 2 sections represent what the other pets are, other. And I see that I can build the bar model the same type of way, and that the scale factor between these two is times by 2. So yes, I know they're proportional. Three to 9 is proportional to 6 to 18 because I can break it up into the same structure on the bar model. Okay, number 2. The ratio of pink flowers to purple flowers in a vase is 6 to 8. So this time they're giving us a part to part. They gave us pink to purple. So I think, okay, I got pink, I got purple, and then I've got a total. They gave us pink to purple is 6 to 8. And then they gave us a different vase, pink to purple is 8 to 10. Okay. So in the first one, I'd have 14 total. In the second one, I'd have 18 total. These don't, this is not reduced, right? 6 and 8, they both reduce by a factor of 2. They're both even. So on this one, that would give me 3, 4, 7 total sections. This would give me, they reduce by a factor of 2 also, 4, 5, 9 total sections. So I know that there's no way that these 2 bar models can structurally be put together. The first one, the simplified version, I have 7 sections of it. 1, 2, 3, 4, 5, 6, 7. 3 of the sections have 2 pink flowers, 2 pink, and 4 of the sections have 2 purple flowers. On the second bar model, it's not being broke down to 7 sections. I can't simplify it down to a total of 7 sections. I can only simplify it to a total of 9 sections. So I know this is not structurally the same. Okay, they have 4 sections of 2 pink flowers. And 5 sections of 2 purple flowers. So I can see from my chart and from my bar model that those are not structurally the same. They're not proportional. So, no. 6 to 8 is not proportional to 8 to 10. Okay, so if we can't make it with the same number of total sections in our bar model, then it's not going to be proportional. Okay, so we're just reviewing from above. Simplified, 3 to 8 is simplified. And this simplifies, we can divide by a factor of 4 down to 3 to 8, and that's why we know they were proportional, because they've reduced the same way. 3/9 reduces to 1/3. 6/18 also reduces to 1/3. That's why we got those are proportional. 6 to 8 reduces to 3 to 4. That's where the 7 sections is, 3 plus 4. This reduces to 4 to 5. That's where the 9 sections are. This is not proportional. Okay, so if your fractions don't reduce to the same fraction, then they are not proportional. Okay, so now we're looking at the same information, but instead of doing bars, we're representing it in tables. It's just another way to look at the same information. Okay, so here, lots of ways to look at it, but I can see on my row, on this one, by my row, I multiply by 4 to get down to the next row. Okay, or I can see it by going my columns. We usually look at columns. I'm multiplying by 8/3 both times. 12 times 8/3 also gets me 32. Okay, on my cats to pets, I'm multiplying by 3. Okay, so I can see if I have a factor between the 2 columns, then there is a common scale factor. You can see if there is a common scale factor between the ratios. Remember, it's a video. I'm going fast. You can pause. You can go back and rewind too. Okay, when we see the table for the pink and purple flowers, we see that it does not work out. Here, 6 to 8 and 8 to 10. We're going to see we do not have a common ratio. We can look all kinds of different ways. If I go from 6 to 8, I'd be multiplying by 8/6, also known as 4/3. If I went from 8 to 10, I'd be multiplying by 10/8, also known as 5/4. These are not the same. Okay? Or I can look at it between the columns too. Here, I would be multiplying by 8/6, which is the same as 4/3. Here, I would be multiplying by 5/4, which is not the same. Okay, so I can see either way I go. So here, the situation is not proportional. There is not a common scale factor. All right, identify for which the 4 tables has relationships that are not proportional and justify why Or why not in words? For each table that is proportional, find the constant that multiplies to get from x to y. Okay. So I'm thinking, 2 times what is 19? 2 times 9.5 is 19. So then I have to check it. 3 times 9.5, yep, 28.5. 4 times 9.5, that's 38. 7 times 9.5 is 66.5. 8 times 9.5 is 76. So I see every time I multiply the x value by 9.5, then it gets me to the y value. Okay, here. I'm trying to get from the x to the y. Well, 2 times a half is 1. Half of 4 is 2. Half of 6 is 3. Half of 8 is 4. Half of 10 is 5. So here I'm saying, I'm multiplying by 1/2, or I'm dividing by 2, same thing, to get to from the x to the y. Here, 1 times 2 is 2, but 2 times 2 is not 6. Okay, so right there I can build a set of ratios that's not equal. 2 over 1 is not equal to 6 over 2. As soon as I find one set of ratios that are not equal, then it is not proportional. All right, -2 times 3 gets me -6. So I check. -1/2 times -3 is -1.5. Or sorry, -2 times +3 is -6. So then I multiply by +3 works, multiply by +3 works, multiply by +3, multiply by +3, and I say, yep, this one's proportional. It's multiplying by +3. So here, yes, the scale factor is 9.5. Here it's a yes. Scale factor is 1/2. This is a no. This one's a yes. The scale factor is 3. Okay, so if we know the scale factor, we can write our equations. Okay, so here, if I want y, I take the x and I multiply by 9.5. So 9.5 times x. Okay, or if you write it in fraction form, 19/2 x is equal to y. We write it as an improper fraction if you're writing fraction form. Okay, so here, this one was y equals 1/2 x. This was not proportional. And this was y equals 3x. So now we can look at a table, and if it's proportional, we can build an equation. That's where they're going. All right, the tables show distances traveled by the 3 trains. So you want to pause the video, try number 8, and then come on back to check your answers. Okay, so I'm looking to see if I can multiply. The zeros are not going to help me. 2 times 60 is 120. So I'm looking 3 times 60, 5 times 60, 6 times 60. I go, yep. I know that this one, to get from the time to the distance, I'm multiplying by 60. So this train is going 60 kilometers per hour. That's its speed, 60 kilometers in 1 hour. Okay, I look at the next one. The zeros aren't going to help me. It just means that there's no head start. 5 times 40 is 200. 10 times 40, 15 times 40, 20 times 40. Okay, cool. Let's multiply by 40. So this train is going 40 kilometers per 1 hour. All right, this last one, 1 times 65 is 65, but 2 times 65 is not 85. So this one is not going in a consistent speed. This is not proportional. I know, because 65 over 1 is not the same as 85 over 2. The train slowed down. So which train is not traveling at constant speed? That would be train 3. 65 to 1 is not equal to 85 to 2. Suppose there was a fourth train. The fourth train is traveling at 3 times the speed of train 2. How will the values in train 4 compare to the table values in train 2? So if it's going at 3 times the speed, it's going 120 miles per hour. So it's going 3 times the speed. I'm multiplying everything in the y column by 3 times as much. Okay, number 9. There is a proportional relationship between your distance from a thunderstorm and the time elapses between you seeing the lightning and when you hear the lightning. This is called a flash to bang. If there are 15 seconds between lightning and thunder, the storm is about 3 miles away. If you double the amount of time between the lightning and thunder, do you think the distances in miles also doubles? Well, it tells me that there's a proportional relationship. So, because it tells me there's a proportional relationship, I know that the scale factor has to happen. Okay? So, if there's a 15-minute lapse, or 15-second lapse, 15-second lapse, it's 3 miles away. Well, if it's proportional, if I multiply part of the ratio by 2, then I have to multiply the other part of the ratio also by 2. So if there's a 30-second lapse, it means it is 6 miles away. If there was a 0-second lapse, that means that you just got hit by lightning. Okay. So since it says it is a proportional relationship, when the elapse time doubles, the distance also has to double. All right, Vegemart sells 3 green bell peppers for $1. If they round their prices to the nearest cent, as shown in the table below, tell them whether you would describe the cost of the number of green bell peppers as a proportional relationship. So this is very like math techy. So technically not, because here there's rounding. On this one they rounded down, on this one they rounded up, because when you go $1 divided by 3, $1 divided by 3 technically gives you 0.3 repeating. Well, here they rounded down and here they rounded up. So really, it's not proportional because of the rounding errors. Okay, so for instance, if I bring 3 bell peppers up, they're going to give me $1. But if I brought 1 up and I did that 3 times, I'd only pay 99 cents. So it's not the same. I would be saving me a penny by not buying 3 and just buying 1 3 times, but then I'd have to stand in line and I wouldn't want to do that. Okay, so you are pausing the video after you read the directions. 11, determine if the set of ratios are proportional by simplifying each ratio. So I want to know, is 7 to 9 the same as 21 to 7. Figure out which ones are and which ones are not, and then come back and just and check your answer. Okay, so on A, you should have got yes. Okay, here I can divide by a factor of 3 to get me back to 7 over 9. So those are matching. Okay, over here I should get new. Here this is divisible by a factor of 5, which gets me to 3/7. And this one is divisible by a factor of 4, which gets me to 6/13, and those are not equal. Okay, C, I should get a yes. I gotta do a little work here. This one's reduced. That one's done. This one is not. 3, and I have to make this into an improper fraction. We barely work with mixed fractions when we're doing algebra. 15/4. That's the same thing as saying 3 divided by 15/4. Cleaning up, multiply by the reciprocal. That is 12/15, which reduces to 4/5. You'll be able to work with those complex fractions. Okay, on D, you should have got a yes. Okay, remember there's lots of ways to do it, but here it said by simplifying the ratio. Okay, so 2/3 is already done. And change this to improper. 9/2. That's the same as 3 divided by 9/2. That's the same as 3 times 2/9. 3 reduces with the 9. And we get to 2/3. Okay, this one's a new. This is reduced. Can't reduce it more. And this reduces to 3/4. So those aren't equal. Okay, this one's a straight off no. I can see this is bigger than the left one is smaller than one, and the right one's bigger than one. This is 2 over 1. This here divided by 3. This is 2/5. Those aren't equal. Okay, so we did it by reducing, but there's lots of ways we can do it. So one way is they reduce to the same fraction. Now you spent 5th grade and 6th grade coming up with all kinds of ways to do this. They can divide to the same decimal. You can see if the cross products are equivalent. You can see if one's a scale factor of the other. Scale up or down from the other. You can draw equivalent bar models. You can create common denominators. There were so many ways that you explored the concept of proportionality in 5th and 6th grade. And this was just a review of some of the things that you did in 5th and 6th grade. Okay, that is the end of 5.2a.